Let's get on with our today's topic. So today's one of the last few topics, and we'll try to make it quick. I know you got a lot of work to do on your assignments and so forth. So again, today we're talking about monitoring your server. Okay, so how do we know we've set up our servers, we've set up our services, and everything's working? Okay, that's great when you first deliver the project. Okay, when you hand over the project, obviously you'll do a walkthrough, you'll do a example, you'll actually demonstrate the capacities of your servers. But obviously, part of that is actually telling the customer what he's getting. Okay, so if you're going to get a new car, they probably want to know how fast it can go and how much petrol it will actually consume per 100 kilometers. So with this network we're going to deliver, we're going to do what's called benchmarking. Okay, so benchmarking is like a way of actually creating a baseline of what is the optimal settings. Okay, so there's a couple of reasons for doing that, and one of the reasons is to actually know what your server hardware is capable of, what your network configuration is capable of, and secondly, it can be used as a way of comparing performances in the future. Okay, so for example, we all know our computer, the first day you get it, you turn it on, it works beautifully. So what happens 6 months down the track? You notice that things are not working so well. Okay, maybe things are taking a little bit longer to boot up. Yeah, where you do perform some action that may have been, you thought might have been really quick to start off with, is taking a little bit longer. Okay, I'm sure everyone's had experienced that. Okay, I'm sure your computer, especially your home computer, probably accumulates a lot of junk, accumulates a lot of rubbish, and it ends up performing slower. Okay, so how do we objectively know that? Is it because we're just becoming less tolerant? Is it because we got used to the new computer and the speed levels that we're used to, and now anything that's slower than what we think it should be is frustrating? So what we do is we create these baselines when the system is delivered, first set up. These baselines are stored as records, and then maybe 6 months down the track we do run the same performance monitors, measure the same counters, measure the performance, and create a new baseline files, and we put them side by side. Okay, we see how the servers are performing. Okay, so obviously not everything is to do with the computer being full of junk or not running optimally. It could be just organic growth. You heard of that term? Like, for example, your users probably never had this particular service, so maybe in the beginning they don't use it to the extent that they would use it later. So over time, maybe their use of DFS, because they know it's there, has increased. Okay, that's fine. That's what you expect. Maybe their use of some other service has decreased. You know how it is with computers and with systems and services. We tend to actually change the way we use computers. For example, how many of us actually burn DVDs or CDs these days? Probably zero in this room. Okay, but if you think back 10 years ago, how many of us actually burned DVDs or CDs back then? Probably every one of us. So that's what I'm saying. Over time, the way you use the computer, the way your users use the computer system and the network will change. Okay, so there'll be some services which were even available 10 years ago. Okay, some of the services which are cloud related, but these days they are. So maybe your internet usage has gone up, but your local area traffic, like file server traffic or maybe stuff like that, has gone down because of the fact you're, instead of actually transferring files across the network from the file server to your work machine, you're actually using some shared folders with OneDrive to actually collaborate on files which are actually stored maybe on this internet only. Okay, so I'm just giving some examples of how the changing way that users use your network. Okay, so today what we're going to do is we're going to look at some of these monitoring tools. We're going to use Performance Monitor, and we're going to monitor the event log. So it'll be hopefully a very quick session. So let's have a quick look at these things. So first of all, there's Task Manager. Okay, so I won't use this PowerPoint to show you this. This Task Manager is pretty much the same on every Windows system. We all know about Task Manager, so I'm just going to start a Task Manager on my Windows 10 system, which is basically your Surface 2016 server, but in a workstation. So let me just minimize everything else so nothing is actually. If we look at this task manager, we all sort of have an idea of how this works. So right here, we've got all the processes that we've started and how many times has something not stopped working and you've actually selected it and you've chose to end task. Okay, so that's probably how most people use the task manager. Okay, so but besides that, there's actually a couple other tabs. So I'll actually, it's actually changed from Windows XP. If you remember from Windows XP, there's a service tab. You know how we'll go to the services management console to actually start services. We can actually go here, like VMware authorization service is running right now, so we can quickly check whether a service is running. We can actually stop, restart, and go to the details, which basically shows us the description, and we can actually look at the properties, and we can look at the security and so forth, but it just lets us see some of the tasks. It's not the replacement for the services management console, but it allows us to have a quick way of accessing this information. We've got the details, which actually basically gives us a little bit more detail of all the programs that's running on our computer. Okay, for example, we've got the names here, obviously. We've got the process ID, and we've got whether the status is running or so forth. And here the username is whose authority are these programs running under. Then here the CPU and memory shows you how much CPU a particular process is using. For example, I'm clicking on CPU, which actually then sorts by CPU usage. Okay, you can see that right now system idle process is 85%, and that's good. Okay, system idle is basically when the computer has extra CPU cycles that's not being used for anything. It just goes to system idle. Okay, so it basically means the higher your system idle is, the more CPU resources there are for anything that needs it right now. Okay, so if that's a high percentage like it is right now, that's great. We can also sort by memory usage. For example, I can see that my link.exe, which is the Skype for Business I'm using to record the video right now, is actually consuming 145 megs of RAM. Okay, we all know that RAM is pretty important for the performance of any computer. Okay, and probably RAM is the easiest way you can improve the performance of any computer by adding more RAM in there. Okay, so obviously we can look at that. We can look at we can look at the description to actually have if we don't understand what the name is, for example, MPENG. Well, if we don't know what it is, here's the description. It's an anti-malware service executable. Okay. So if we go to users, we can see which users are actually currently logged into this computer. And obviously, if this was a server, you might have multiple users logged in. That might be because they've opened up sessions that they haven't closed off. So they just switch users, or they might be logging in using remote desktop or the remote desktop services, which is basically having separate sessions of remote desktop as the operating system. We've got the startup. This is an important one. Like basically, it tells us what programs are automatically going to be started up at the point of time when your computer starts up. Okay, so right now, if you look at these, they're enabled. If you look at the startup impact, you'll see that because I'm starting up, let's say Skype for Business, this particular one has a medium impact on the startup. What does that mean? That means it has impact on how fast our computer starts up. So you know how it is. When you start up a computer, there's a whole heap of things being loaded in the background, whether you see it or not. And basically, these are some of these things. And let's say I've got QuickTime. It's got low impact, but really, I don't want QuickTime to start up every time my computer starts up. I personally don't use QuickTime myself. I can look at the details. I can actually disable, which means that next time my computer starts up, that won't actually start up. So those are things we can actually configure. So this actually, if you ever use the msconfig in previous versions of Windows, and we will go to the startup tab to check which ones started up and whatnot, this actually replaces that. So if I actually go msconfig which is what we used to use to open up the configuration. Like for example, this is where we can actually configure the startup of a Windows. Okay, whether it starts up and loads, it has the boot. If you've got multiple boot operating systems installed on the same computer, we've got the various services which are started or running, and we could actually disable these services from starting up. But here's the startup tab that I was referring to, and that is actually being transferred into your task manager. Okay. If we go to app history, this again gives us a bit of a, tells us a bit about how much time it's been running, how much network resources is consumed, and so forth. You can see my computer basically hasn't started up for too long, and you can see that some of these things have consumed so much network bandwidth. But the tab that I'm probably more interested in looking at today is this performance tab. So here we've got our 5 major resources. CPU. Okay, we all know what that is. That's how busy the current CPU is. You can see my computer is not very busy. Okay, so this is 100% up here, and this is 0% up here. You can see it's just about 13, 14%, 12%. It's just fluctuating as it all does. So it's not very busy right now. It's probably we're not using most of our CPU resources. Down here we have so this graph gives you a bit of a history, not too long of a history, but history as far as if you go 60 seconds, 0, so it's about a 60-second history. So this is not meant for doing the benchmarking that we're talking about before. This is meant to give you sort of a real-time feel about what your computer's doing. So if you look at down here, it gives you more of a numeric representation. So it's 11% busy right now. So this is not talking about anything to do with the history. It's talking about right now, real live data. If you look at the speed, this is the speed that your CPU is being using. This is how many processors, how many threads, how many handles, and well, the uptime now is about, I believe that's 11 hours and so forth. I'm not sure why it's that, but if we look at there's other major resources is memory. Okay, so memory again, like I said, is very important to a server or to any computer. The more memory, usually the rule is it's better, and the easiest way to improve the performance of any computer is to give it more RAM. But again, if you look at my particular computer right now, again, this is live information. You can see it's not consuming all of the RAM. It's got 16 gigs available, but it's really only using about 3 gigs of it. Okay, so you can over here you can see that there's the memory consumption. It's more of a bar graph. There's some standby. There's some memory that's being modified as we speak. It's probably because I'm actually recording this video. And here we've got our numeric representations of how much memory is being used. If we look at this here, it even tells us that we got 4 slots of memory. They're DIMMs. And we've got the speed of the memory is 1600 megahertz. And so forth. Obviously, the disk resource, again, this is disk activity, how much is being written or read from the disk. So this gives you a basic measure. It tells us what hard drive we've got. In this case, my local hard drive is a Lighton 256 solid state hard drive. And you can see there's not much disk activity right now. And that's probably because we're not doing very much. All of the disk activity is probably due to the fact that I'm recording as we are presenting this video right now. If you look at your Ethernet, this is your network traffic. You can notice I've got 3 Ethernet connections. Can anyone maybe think of why I've got 3? You know I've got 1 physical network here, don't we? Yeah, they're the virtual network adapters. Okay, so you got VMnet 2, VMnet A, which is VMnet 2, that's actually a custom one. That's a host-only network, I'm presuming. And VMnet A is the NAT. And we've got the actual physical network card, which is where our traffic, you can see there's some activity. Obviously, there would be activity on these other virtual network adapters if there was actually communication with the various virtual networks. But like I said, this gives us some live information and it's great. It's good for a first glance. If my computer wasn't working properly, I'll probably open up the performance tab and I will look at what is maxing out. Is the CPU maxed out? Is the memory getting too low? Is the disk activity too high, or so forth? But this doesn't give you all the information. Okay, so I like to use a tool called Resource Monitor. And this looks a little bit more old school because it's pretty much the same look as it was probably 6-10 years ago. But again, we've got our overview tab, which actually gives us the 4 major resources: CPU, disk, network, memory. Okay, we can look at various, like for example, it's a bit like the task manager tells us what processes or what programs are using memory, what processes are actually sending and receiving traffic, what processes are reading or writing to the disk, and obviously what processes are using the CPU. So this is an overview. Again, this is an overview, and again, you've got these graphs which gives you live information, and again, it's very, very basic information, not the detail I sometimes want. But if you click on one of these tabs, you can look at CPU, and here you can look at the various different services and what percentage CPU they're using, the different handles, well in this case there isn't any, the memory, again what is consuming what amount of memory, and in here this bar graph tells me that there's actually some which is in use, some which is on standby, and a lot that's free. And obviously there's the network, again showing us the TCP/IP connections. This is an interesting one because this is actually showing me the ports that's connecting on. That's interesting. So I know that my OneDrive is using HTTPS in this case. Okay, and this one is using HTTP, connecting to someone using HTTP. You can see there's a whole heap of HTTPS, and this 445 is I believe the network sharing, and there's a whole heap of other ones which is above 1024, which is user defined. So you can actually look at receive bytes per second, sent bytes per second, and so forth. Okay, and you can look at how many TCP/IP connections. But the one that we're probably most interested in for us in this class is probably disks. Okay, if you notice, every time you've called me over and said my virtual machines are not running properly, I'll probably open this and I'll look at this particular counter called disk queue length. Okay, so if you haven't heard me talk about this, we've sort of talked at every level you've probably had me as a lecturer, where we do a lot of virtualization, lots of virtual machines running at the same time. They're all competing for the different resources. Okay, they're all competing for the different resources, and obviously CPU, RAM, and all that kind of stuff, that's fine. And obviously when one resource is a shortfall, then that's where the virtual machines really slow down. So what I find is most of the time, the resource that is the bottleneck, the resource that has the most impact on our virtual machines running properly is actually the disk. Okay, we spoke about how we have different types of disks, mechanical disks, solid-state hard drives, and so forth. So if you've ever used a mechanical hard drive and run more than 2 virtual machines on that at the same time, you may have noticed that they run really, really slowly. But if you open up this resource monitor and look at this disk queue length, you would see that this is a really large number. And what do I mean by a large number that's bigger than 0. Okay, disk queue length is really how long is the queue. Okay, just like you go to McDonald's at lunchtime, you might be really busy. Okay, so there might be a long line for people to get their orders and get their food. So obviously, if we had a mechanical hard drive, it's when we do virtualization, we have lots of virtual machines as well as the host operating system all wanting to read or write to the hard drive. So they're all different types of operations. So when we actually are using a mechanical hard drive, it's like you go into McDonald's and you just like at lunchtime, you you've gone with a large group of friends. Let's say with this whole class, we've all gone to McDonald's for lunch, and we all show up at the same time, and we want to order our orders. Or at this point in time, there's only one person behind the counter taking our orders. So you can see that we're going to form a really long line. And most of us are going to get upset and grumbly because it's so slow to order our food and get our food, even though it's supposed to be fast food. If you compare that to a solid state hard drive, it's like you go into McDonald's with this whole class again, but instead of having one person behind the counter, they had 10 people behind the counter, taking your orders and making your orders and so forth. Okay, instead of us making one big long line, it's actually going to be divided over 10 different people, so we're going to have a lot shorter lines. Okay, probably maybe not even any lines at all. So basically, this queue length is things waiting to be written or read from the hard drive. So an operation that's performing on the hard drive. So basically, if you want to think about it, that's the line at McDonald's. Okay, we have a solid state hard drive. So therefore, the line's going to be very small. Even when we actually start our virtual machines more than 2. You'll find that most of the time when your virtual machine's up and running, this is close to 0, if not 0. Okay, very close to 0. If it's above 0, you'll find that one of your virtual machines is really not responding very well. Okay, so if you compare it to a mechanical hard drive, this will sometimes be up to 100. Okay, so this is the reason is that a solid state hard drive has a lot higher IOs per second. We've spoken about that. That's output operations per second. Okay, and usually for virtualization, that is the highest. That is the counter. That is the thing that is actually going to be our bottleneck most of the time. Okay, so therefore, if we have a solid state hard drive, it's going to have a lot higher IOs per second than a mechanical hard drive, and this line will be lower. But you can see that I can just for understanding what's going on the computer, I can start up the task manager, I can start up this resource manager and quickly get a read on what's happening on my computer. If something's not working, I can quickly identify, hey, maybe that's the reason. Maybe that's the reason because I can see how it's performing. It's a bit like like you're driving your car. You're driving your car, you can look at your speedo to gauge your speed, your what's a odometer to see how far you've gone, your revs, revolutions per minute to see how hard your engine is actually working. So it gives you sort of an idea of what's happening right now. So the problem with these tools is good for showing you what's happening right now. Okay, so let's go back to our PowerPoint before we go any further. So I won't talk about this too much here, but what's happening right now is great. But what we want to do is actually we want to actually not only know what's happening right now, we want to be able to measure and monitor these performance over a long period of time. Remember what I said? If we create a baseline when we first deliver our project and we measure the performance of the servers of our network, we can know what's optimal. 6 months down the track, we do the same. What's a baseline protocol, which basically measures the same type of counters at the exact same time in the exact same way. And then we put it side by side and we compare it. If we realize that our network traffic has gone up significantly between then and now, we have to work out what is the reason. Is this a dramatic increase or is it a progressional increase? So it could be more than one baselines we're comparing. Could be day 0, 6 months, a year, year and a half, just putting them together and comparing over time. Okay, if you see it's a dramatic increase, then you have to understand why is it happening. Is it because we've just installed this new DFS server and it's doing a whole heap of replication across the network and therefore the network traffic was high in that period? Or if that's not the case, then that could explain the traffic. But if that's not the case, if you can't find some reason to explain the traffic, maybe there's something wrong. Maybe there is a network card which is actually faulty and is actually sending just rubbish on the network. Okay, so flapping network card. Have you ever heard of that term? So where it's just like sending useless junk because there's something wrong with it. Okay, is it a smooth progression. Okay, if it's not a dramatic increase, it's a smooth progression. If it's a smooth progression, as in it's sort of you sort of increasing progressively, that may mean that it's just a way your users are changing the way they're using the systems or network. Well, if you can see they're using it and it's getting to a point where if you're getting to the upper ceiling of how much network bandwidth you have, the other thing we can do with this performance monitors or baselines is actually take preventative maintenance and take preemptive action. Okay, what does that mean? If I know that the network is actually amount of network traffic, just to keep it simple, is increasing, maybe I should actually investigate in getting faster devices in my backbone network. Okay, so for example, the servers are now all, let's say it's all connected with gigabit network. That's fine, that's really great, but we all know that the servers are going to get more traffic than a regular computer, right? So maybe we should investigate maybe 10 gigabit networks cards. Okay, what about the idea of NIC teaming? Okay, we can NIC team lots of network cards together on the server so it actually can be load balanced. So basically, if we're seeing that traffic is going up and up, maybe we can do some of those actions before that becomes a serious problem for our users. Okay, so take preventive actions. If we can see that if we're monitoring other things, like for example the hard drive space on our file server is going up and up and it's getting to 85% full, maybe the preventive action could be introduce data deduplication, okay, or get more storage, or set up quotas. So we got all these things, but we need to understand how people are using our computers, and that's what the monitoring is all about. Okay, understanding how people are using it, when potential problems could crop up, and also using these baselines to compare time periods to understand the changes in your network, if it's progressive, or if it's not progressive, if it's dramatic, it could be a problem. Okay, it could be a problem, it could be malware, it could be a worm on your systems, and that's causing a dramatic increase of resources. Okay, so basically part of troubleshooting is experience. Experience is when you know your system so well that you know that that's something wrong. I'm sure you notice this at home. Okay, you notice this at home with your computer. You could probably, even if you don't, you sort of like you look at your computer or you use your computer, and when something's not running properly, you probably know that just took like an extra minute to boot up, or extra 30 seconds to boot up. Even though you may not be able to measure it yourself in that time, but you know that took a little bit longer. Okay, if it gets to that point where it's getting ridiculously wrong, then you actually would do something, wouldn't you? Okay, so that's what knowing what's normal and knowing that something's off. Okay, so if you know your car, you know your car always drives like this, and one day it's sort of making a different noise. You know it's off. So that's because you know what's normal. When you're working in a network, when you're working in a company, you don't know every computer, you don't know every server that well. Okay, hopefully over time you do, but maybe you don't. But by monitoring and benchmarking and baselining, it's a way of actually, not just have your gut feel, oh, that's a bit wrong. I know that's wrong because I can see on this graph the network usage has just gone up by, threefold. Okay. So when we use performance monitor, okay, so that's performance monitor again is that previous diagram here. This is a performance monitor. This tool allows us to monitor the server or any computer, but we are able to save what we're monitoring. Okay, we could do it like, for example, on the day we deliver our network, we could do some performance monitoring. We can actually create these baselines, and we can monitor some performance counters that we are interested in. But we can actually save this. Okay, so on any computer, so if we go to this Windows 10 computer, we've got this performance monitor, and we've got performance monitor right here. And it's just empty graph. It's empty graph because we haven't added anything in there yet. Okay, so we can add what's called performance counters. Okay, you can see it's There's so many different types of counters. You just have to you have to know what you're looking for. Okay, so if we're interested in, if we've got specifically Hyper-V problems, we have various counters to do with Hyper-V. So if we stick with what we know already, which is like, well, we knew processors, didn't we? Well, we know, here's a processor. So under processor, which is the CPU, if we open this up, there's a whole heap of counters to do with processor. Processor time, for example, and this is actually what percentage of the processor has been used, a bit like that. But there's a whole heap of other counters. For example, there's interrupts per second. So if you've never heard of what's an interrupt, it's basically the CPU is busy doing something, but the user's using the computer and the mouse. Well, if the user clicks on something, it needs to interrupt the CPU, say, hey, stop that for a second, do this for the user. So that's how interrupts per second means how many times per second is the CPU being interrupted or being pulled off what it's doing. You can see that you can probably obviously understand if the CPU is being interrupted too often, it means that it can't ever get its job done quickly. It's just like if you were like a kindergarten teacher and you had all these children in the class and each one of them going, teacher, 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 you sort of would be always addressing what they're asking you rather than what you need to get done. Okay, so but I'm not going to be here to go through every one of these counters, unfortunately. There's just way too many to go through right at this stage. So if I were you, if before I would implement some sort of baseline, I would do some research or what counters to use. What counters to use if I want to measure an aspect of my server or aspect of my network performance. Okay, so obviously there's a few that's pretty obvious, like processor time, memory usage, and so forth. If I actually put that in there, and you can see there's two counters now, there's processor time and interrupts per second, and you can see there's two lines going up and down on my performance monitor. Again, this is live information. This is live right now. So we can use it to look at live information right now as well, but we can also use it to actually save the settings. We could save the settings, like we added a whole heap of counters. We can save it so we can use it again and again. So at the 0 day mark, the 6 months mark, 12-month mark, do the same settings and measure the same counters. We can also log this to a file. We can also change the graph. So it's a line graph right now. It's pretty useful. With the line graph, you can obviously see the line. But you can, down here, you can also see, if I select the green one, you can also see some numeric values down here. Okay, this is specifically the one I've chosen. If I select something else, it will tell me the numeric values of that. We could also change the view to histogram instead. So instead of looking at a line graph, which is probably a little bit more useful, I think, in my opinion, because it gives you a bit of a history that you can scroll back and forth. This actually just shows you the two counters we're measuring here, and it's just fluctuating up and down, giving you that point in time view. We could also change it to report graph. So instead of having something visual, graphical, we're having just numbers fluctuating as the different counters fluctuate. All right. So again, we can pause, we can log it, and we can actually create what's called data collector sets. Okay, so in our worksheet, this will make a little bit more sense. We can actually create what's called a user-defined data collector set, and we can actually put various counters in. Yeah. And we could actually look at the various counters, add or remove different counters, but you've got a little bit more in your server. Obviously, one of the requirements for your assignment was that you actually monitor Active Directory. Okay, so that's a little bit different to what we do in the worksheet, but it's not so out of the ordinary that you can't work it out. Okay, so let's get back to our PowerPoint. So like I said, you've got various counters, okay? Various counters to do with physical resources, like the CPU, like the disk, like memory, like network. But there's other things as well, like Active Directory, like the .NET framework, like the hypervisor. So there's so many counters associated with so many different services. Like I said, it's not something that you're going to know every counter instantly. It's one of those things where I want to monitor the hypervisor, or it's a Hyper-V server. I want to monitor this hypervisor. So what counters should I use? Maybe at that point in time, do a bit of research, work out what counters to use and what they will tell you if they're high or low or whatever. And at that point in time, set it up. So we spoke about the resource monitor. There's also a reliability monitor, which monitors the hardware and software issues and provides you a stability index of 1 to 10. And 1 obviously represents the lowest stability and 10 represents the highest stability. The reliability monitor window component includes a historical report of the stability index, reliability details, and actions to be performed. So saving historical data, starting problem report console, checking online for solutions. It's one of those things that probably helps you diagnose what's going on with your computer or server and helps you identify things that potentially could be wrong. And let's look at Event Viewer. So Event Viewer, so we've sort of spoke about this previously because there's an Event Viewer for pretty much every item you've got installed on your server. So obviously I'm using my Windows 10 here, so I'm not going to have as many, but I've got my default application logs. So don't forget, event logs are just your logs for your Windows operating system. So application, this is to do with all the programs that I've installed. I've got some big red errors here, if you can look at that. But you've got various ones. You've got information, which is not very important. You've got heaps of those. You've got your warning level. And you've got your error level, which is probably the critical one. So if we look at the system, this is the operating system logs. Okay, so we will already use the security logs in our auditing. But this operating system log, there's an error here. The application specific permission setting for local activation permission for the COM server, some error message. Okay, and obviously with this error ID, and if it doesn't make sense to me, with this error ID, with this just error message, I can go to Microsoft TechNet and do a bit more research and understand what this error actually means. So in Microsoft Server, you're going to have a lot more under applications and services. So for example, you install DNS, suddenly you'll have a DNS log. You install DFS, you got a DFS log. You install Hyper-V, you got a Hyper-V log. So it's pretty much all your log files for your various different services, and you'll go to specific ones. But what if I want to? What if I don't want to go to every specific computer and look at their logs one by one? Okay, so if I have 20 servers on my network, do I need to go to every one of those servers and look at the logs one by one? That's annoying, isn't it? Especially if I have to physically go there. I can use a remote desktop and I can just switch between all the different machines, but it's still a little bit annoying. So what we can do is we can actually create what's called a subscription. And this is where we get a computer, like one of the 20 servers that I just gave an example of, to actually send me forward events to my computer here. Okay, so instead of me going off to 20 machines and looking at their event viewer, I just go to my local machine, go to these subscriptions, and have a look at all the different logs that's being forwarded to me from the other servers. Maybe I don't want to have every possible thing that's forwarded to me because that's just a lot of information. Maybe I just want the critical and warning instances forwarded to me. Okay, so this is where we'll create one. But obviously in your worksheet, that's what you'll do. And obviously in your assignment, that's one thing you have to do is to forward the RAS, the remote access server logs or events to the file server. So that's from the RAS server to the file server. Okay, so from the file server, I can see the events from the RAS server. Okay, some people in the past have done it the opposite way around. Okay, that's a common thing that people sort of get it wrong when they do it. All right, so Event Viewer provides the ability to view multiple logs, create custom views, create task schedules to run in response of events. So to create and manage event subscription. So Event Viewer has many built-in logs such as your application, security, setup, system, and forwarded events. When we talk about that forwarded events, that's what we're talking about when we have other computers forwarding our events to us. Okay. So the Server Manager console, so installed by default in your server and can be installed onto your workstation computer as well. It supports monitoring of the Windows Server operating system and provides a centralized monitoring dashboard. Okay, so I don't have, let me see if I can turn that on for you. So we've only got one server here, but from that Server Manager, we know, hopefully you know that besides managing the local server, we can add extra servers in there. We can manage other computers that's on our network. So like I said before, instead of going to every other computer and opening up Server Manager and doing your thing, if you can set it up so that your Server Manager can connect to other servers. So unfortunately, I've only got one server here. Let me see if I've got another one. Maybe. Oh, yeah, no, that's fine. So I'm going to start that up as well, but okay. So let's see if we can log in. So as we all know, the Server Manager actually starts up automatically, and we can obviously tell it to go away if we want to. But if you notice, we've got the local server, which basically means this computer right here. Okay, so we can actually see that there's actually some information about that, and we can look at some basic information. But if we click on all servers, you can see there's actually just server 1 right now, but I can actually add a server, and hopefully, let me see if that's running already. Yep. The server 2, if that's part of the domain, it's pretty easy. It's already trusted. It's in the domain, and I can add. And obviously right now, it's gonna now query the server 2, and it's telling me it's not activated, but basically now from here, I can actually look at the events from server 2. And I can look at the services on server 2. And I can actually do a best practice analyzer scan of server 2. And this is where it can actually recommend some things to do. And here I can look at the performance of server 2. So it can configure performance alerts and so forth. But this is just another way of doing things. Okay, just like in the worksheet we show you the performance monitor, but pretty much it's all the skills are transferable. It's instead of doing in that interface, you're doing it here. And with this add roles and features, remember how we added roles and features to the local server? We can add roles and features to now server 2. Well, actually beyond server 2. So remember how we talked about how we have different types of server like nano server and server core and so forth, like servers that don't have a graphical user interface. We also said doesn't mean that you can't use graphical user interfaces to still administer them. Okay, so from here we can still connect with this one, for example. Then we select server 2 instead of server 1. So obviously in our worksheets, we don't do that. We say switch over to this one because it can get very confusing which one you do, especially if you're giving instructions to someone who's never done it before as to what. Like just imagine I say install DFS and you accidentally select server 1 instead of server 2, then you might get it totally wrong. So that's why we sort of tell you to switch computers specifically so you don't get it right. So but if I can choose server 2, I can choose to select the different service roles and so forth. Okay, so this is just showing you that from Server Manager we can connect to other servers and we can look at server 2's disks, for example. So we can use Server Manager as a central place to manage lots of servers. Okay, so not just the local server. So that's the way we've been doing it so far, and that's just so we can actually get in our mind, this is what we're doing on this particular server. Whereas in reality, we could have done, we could have sat back and did all our configuration from one computer, couldn't we? Really, potentially, we could have. But obviously, that's a little bit more advanced, and you need to get things twisted in the right way in your head before you can actually understand what you're doing, especially when you're learning something new. So that's why we didn't do it like that. So basically with Server Manager Console, we can connect to lots of other servers on our domain. If it's on your domain, it's really easy. If it's not on your domain, then it's a little bit more complicated. But obviously we're talking about the situation of a regular domain computer. So it provides a centralized monitoring dashboard and analyzes and troubleshoots different types of issues, identify critical events, monitors the status and best practice by using the best practice analyzer tool. All right, let's actually have a look at this. So we spoke about this sort of right at the start of the lesson. So performance baseline trends and capacity planning. So that's knowing how your system is, and we know over time how it's actually changing. Okay, remember I talked about creating those baselines and benchmarks so we can compare it over time. When we can compare it over time, we can see that things are changing. The amount of network traffic increasing or decreasing, amount of space on our hard drives increasing, decreasing, the usage of memory on our server. We started today, probably not much memory used, but if we look at 6 months time, its memory is being used quite a lot. Maybe that indicates that we should do something. So by calculating performance baselines for your server environment, you can more accurately interpret real-time monitoring information. By establishing a baseline, you can interpret performance trends. So what's happening? If this is a trend and I know that it's increasing at this rate, and I know my limit is here, and I can maybe predict that not right now, it's fine right now, but maybe in another 6 months time, the amount of resource that I have for that particular resource is going to run out. Maybe I do something then. I do something before it runs out. I do some preventive maintenance, being proactive. All these key terms that people like to throw around. What do they actually mean? Okay, proactive, preventative means doing something before the problem occurs. So if we know we're going to run out of memory in 6 months' time, maybe we upgrade our server before that time. Okay. If it's a virtual machine, very easy. If it's a physical machine, obviously means you have to order the physical memory, work out if your server can take the extra memory, and then install the memory. Okay, so by establishing baselines, you can interpret performance trends, performance capacity planning, and identify bottlenecks. Okay, if you've never heard of what a term bottleneck, it's basically what is the slowest thing? What is holding you back? So if you've gone to the football over the weekend or so forth, you know that everyone just walks on the main street, but when they get to that footbridge, they all sort of slow down, don't they? Because we all have to squeeze on that footbridge. And that footbridge is narrower than the highways or the roads that led up to it. So therefore, that footbridge is slowing the traffic of people from one side of the River Torrens to the other side, going from Rundle Mall to, let's say, Adelaide Oval. So that is what we call a bottleneck, the slowest thing that's affecting your performance. Let's talk about your home computer. Okay, your home computer might be like a super duper computer that you spent $6,000 on, and you have the latest greatest everything, but you're playing this internet game, and it's really slow. But what's slow? Okay, it's not your computer. You probably identified that your internet speed is maybe too slow. Maybe you're using ADSL 1 instead of ADSL 2 plus. Maybe the copper that's in your area is actually not capable of giving you higher speeds. Maybe your distance from your house to your exchange. Okay, maybe your best friend's got the NBM already, and even though he's got a worse computer than you, he's able to play that game a lot better than you because he's got better connection. So just for your home situation, your bottleneck is your internet connection most of the time when you're talking about activity that's associated with the internet. Okay. So for our network, for our servers, if we identify a bottleneck, and if it's a severe bottleneck, maybe we can do something about it. Okay, so if we identify our bottleneck as the network card being 1 gigabit, maybe we investigate that there might be 10 gigabit network cards. Whoa, we might have to update our switches to accommodate that 10 gigabit network card because, hey, if we get a 10 gigabit network card on our servers, but it only plugs into a gigabit switch, it's still going to work at gigabit, isn't it? So that switch becomes the bottleneck. You get me? So one point is something will become the bottleneck. There's never a way of actually removing all bottlenecks because there's something will always be the bottleneck. It's just that you want to make sure that that bottleneck is not so small that it's actually affecting everyone's performance dramatically. There will always be a bottleneck, but you'll want to reduce it and make that bottleneck as little impact as possible on your performance. Analyze performance trends to predict when existing capacity is likely to be exhausted. Like I said, if we see an increase in our memory usage on our server going steadily up, we know this is our maximum, and we know this graph is going steadily up. We could almost extrapolate that graph and work out when that's going to hit that limit. Well, if that's 6 months' time, that still gives us a bit of time to do some planning, to do some upgrades, to do some mitigation. If you don't know what mitigation is, make that impact less. So maybe upgrading the amount of RAM. So we can plan the capacity of key hardware components, processor, disk, memory, and network based on analyzing these trends. What are data collector sets? Data collector sets enables you to gather performance-related and other system statistics for analysis. So capturing those counters. Okay, that we're talking about. Data collector sets can contain the following types of data collectors. There could be performance counters, there could be event trace data, or system configuration information. What are alerts? Alert, you guys all know alerts. Basically, you probably have one of these at home, a smoke detector at home, right? Everyone's got one. When it detects smoke, it goes off, doesn't it? It goes off, and it's very annoying. So you have to do something about it. Okay, you can't just turn it off. You actually have to remove the smoke or remove yourself from the noise. So obviously we all know why smoke detectors there is to warn you because there's smoke. If there's smoke, there's fire, right? So there's a chance your house is burning. Or you've burnt your toast, or you've cooked something and it has made a great big smoke, but obviously at least you know about it. You're not going to be unawares in the whole house. You're not going to be sleeping and not know you've burned your toast. Okay? So that's what these alerts are. So basically, what are alerts here? So basically, when we're measuring something with our performance counters, wouldn't it be good if something just popped up and said, hey, the amount of memory on your server usage is just hit 90%. Wouldn't that be good? Instead of you actually be constantly watching it. No one's going to be constantly watching it, are they? It's great to have that logs and all those performance things and ability to look at the live data. That's great. But wouldn't it be good if something actually told you about it instead of you having to look at it? Okay, that's like this alert. An alert notifies the administrator of an event that has have occurred or a performance threshold that's been reached. Okay, when creating an alert, configure the following. Configure the alert when something happens. Okay, let's say we're talking about memory. That's something easy to example. Okay, so if the system memory usage is getting up above 90%, that's a bit too high, isn't it? Maybe let's make it 80%. Okay, the alert triggers when the amount of memory on our server gets to 80% usage. Okay, everyone understands that easily. So what happens then? Well, how it triggers. Obviously, it's going to show up in our event viewer and so forth. But what else could happen? An alert action. We can configure it to run a program. We can configure it to send an email, and we can actually obviously log it to the event viewer. And don't forget, when we say run a program, that could be a script, that be a third-party program that sends an SMS to your administrator's phone. Okay. So what is the alert task? So basically, when we create alert, then what do we do when it triggers? Monitoring network infrastructure services. So monitoring is essential for optimizing network infrastructure service performance and troubleshooting of servers. Okay, so now we're talking about the traffic that goes through your network. So we all know that there's good traffic and there's bad traffic. There's traffic that's legit, as in you guys going to learn on which is hosted on the cloud and accessing your files so you can do your worksheets and your assignments and so forth. But there's also traffic. We know that someone's gone to YouTube to watch the latest rap video or the NBA playoffs or something like that. Or you know how it is. Sometimes some traffic is good, some traffic is not good. So we can also monitor these things, these traffic, okay? And monitoring the servers, how they're utilized, and the different protocols that's being used. Considerations for monitoring virtual machines. So obviously what we've been talking about is physical machines, okay? But we all know that physical machines are not necessarily the most common type of servers, are they? Most commonly, your server is going to be a virtual machine. So you have to take that into account. So considerations for monitoring virtual machines. The virtual machines must be assigned sufficient resources for their workloads. So we all know that we give a virtual machine a certain amount of CPU, certain amount of RAM, certain amount of disk space, and obviously networking. If a virtual machine runs on a host, ensure that that host has enough resources to supply for all the virtual machines it's running. We all know that when one virtual machine is busy, it affects the other virtual machines which is on the same host, doesn't it? So maybe when you get to the virtualization subject, you'll know that we can actually sort of monitor these resources in the virtual world and also place limits and reservations on these resources. What does that mean? That means, hey, should one computer which is really busy affect all the other virtual machines? Or do we place a limit on how much of the physical resources a virtual machine can consume, even if it's busy? We all know that not all machines or not all servers or not all virtual machines are equal. Do we say that the DHCP server has just as much memory as, let's say, the DFS server? Probably not, okay? So we can actually do what's called control resource. We can actually place limits, give them shares, give them reservations. So resources are shared, so performance of one virtual machine can affect the performance of other virtual machines. You must remember to monitor the resource utilization on the host as well as the guest. So when you're monitoring your server and it's a virtual machine, don't forget to monitor the host. The host is probably a little bit more important in that situation because it's actually having access to the real life resources, whereas the virtual machine only has access to the resources that the host gives them access to. Okay, event logs. So Server Manager provides a centralized location for event logs from remote servers. So event logging is enabled by default, and we can actually, it can be categorized by different technologies like Active Directory, DNS, remote access. So there's many different logs. There's customized views, so we can create a query for specific types of events to be displayed. So maybe we want to only see error level events that's generated by the server 1 operating system. And we can do that query or do that filter and only display those kind of events if we wanted to. All right, so basically here again, we can create a custom view. So it's the type of level, when, maybe we instead of any time, we can say the last day, which logs and what categories. And again, when we actually do the worksheet, this becomes a little bit more obvious. like we talked about, we could actually create what's called subscriptions, which means that instead of actually going to each one of these computers and looking at their event logs individually one at a time, we can tell them all to forward their logs to this one computer. And from here, we look at the various subscriptions and we can look at the different events that's happening on those servers or computers. All right, guys, so that's the end of this PowerPoint, and it's a relatively quick one. So what I want you guys to be working on now is probably